Now we are going to derive relation for energy of electron in the n shell. We know the relations for radius and velocity. So for radius is equal to n square h square upon 4 pi square mk e square into z. This relation we are going to use in this derivation. Now total energy of the electron is actually because of kinetic energy and potential energy. Electrons are revolving, so it has a certain kinetic energy, and it is revolving in a certain selected orbit, so it has a potential energy also. But what is kinetic energy? Kinetic energy is equal to half mv square, but the value of mv square is equal to that we are deriving from that Coulombic force is equal to centrifugal force. So that is mv square upon r is equal to k z square upon r square. So mv square is equal to k z square upon r. I repeat, Coulombic force is balanced by centrifugal force. If you recall the derivation for radius, okay, in that we are starting with that concept. So centrifugal force is equal to k z square upon r square, and centrifugal force is equal to mv square upon r. Therefore mv square is equal to k z square upon r. So kinetic energy is equal to half k z square upon r. Well, potential energy is equal to minus k z square upon r. Okay. Now, so the total energy is equal to, substitute the values, kinetic energy and potential energy. So the value is coming as minus k z square upon 2r. But what is r? We have already derived relation for r. So I will substitute the values. So total energy is equal to minus k z e square upon 2 multiplied by the value of r n square h square upon 4 pi square m k e square into z. So now the question comes, sir, whether there will be question based on derivation. See, they will not ask you derivation part, but it is very important to know how are we arriving on the formula. Now why that is important? There are number of formulas. Here we have seen the number of formulas. It is very difficult to remember those formulas. Even if you remember at the time of examination, it is very difficult to reproduce. And for that purpose, it is very essential to know how are you arriving on the formula. So it is not a kind of a derivation actually. It is a process of arriving on a result which we are going to apply while solving the problem. And in IIT, they will not ask you a question directly based on a formula. Sometimes they may ask you a question from these steps also. So if we know these steps, it is very easy to solve the problem. So as we know this R, the total energy ET becomes minus k square z square e raised to 4 then m 4 pi square divided by 2 n square and h square. So total energy is equal to minus, so it becomes 2 pi square m k square e raised to 4 z square divided by n square and h square. So I am purposely writing a simplified version in some different color now. So 2 pi square m k square e raised to 4 upon h square, okay, and z square upon n square. Now we know pi 3.14, we know mass of electron 9.1 into 10 raised to minus 31, k we know 9.1 into 10 raised to minus 11, e we know 1.6 into 10 raised to minus 19, h Planck's constant. So this ET becomes this value, so there is a minus sign also, minus 2.18 into 10 raised to minus 18 z square upon n square joules per atom. Okay. Now since every time we cannot use this number, the 10 raised to minus 8 power, even the calculation becomes very difficult. So we are converting joules into electron volt. So 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. So this is the relation we are getting. Total energy is equal to minus 2.18 into 10 raised to minus 18 z square upon n square joules per atom. Now this number every time creates a problem while calculation. So we are simplifying it, or rather we are converting into another unit, and that unit is electron volt. We know that 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. So if we convert that, we are getting the value. So total energy one electron volt is equal to 1.6 into 10 raised to minus 19 joules. So total energy becomes minus 13.6 z square upon n square electron volts per atom. Now this is for an electron which is revolving in an nth shell. So if there are number of shells, we can accordingly change it. Okay. Now we will understand two different enthalpies, two different energies. First is ionization enthalpy. Energy required to remove an electron from the outermost orbit of an isolated atom. Means actually we are removing electron, we are taking away electron from the nucleus, away from the nucleus. So in terms of Bohr's theory, how can we represent, how can we write here? Here the electrons is removed from ground state, that is N1 to infinity. What do you mean by this? If I consider, let us consider N1, or if we consider N1 is equal to 1. So N2 becomes infinity. What is the energy associated with this? E1 is equal to minus 13.6 z square upon 1 square, right? And what about E2? That is 0, because 1 upon infinity is 0. So delta E is equal to E2 minus E1. So we have 13.6 z square electron volt. So for hydrogen atom, delta E becomes 13.6 electron volt. What do you mean by this? This means the ionization enthalpy of an electron present in first shell of hydrogen atom is 13.6. Means this much amount of energy is required to remove electron from first shell. So this is the concept for the ionization enthalpy. Now if we consider, so now it is not necessary always N1 is equal to 1, because in a hydrogen the outermost shell is first shell. But for other elements we can use this concept where N1 may be 2, 3, 4, 5, anything. But N2 is always infinity. Now I will go for the excitation energy. Now what do you mean by excitation energy? Here actually we are jumping electron, we are allowing electron to move from lower energy shell to the higher energy shell. So the energy required to move electron from lower energy shell to higher energy shell is called as excitation energy. So here it is always N1 to N2. Okay. So if I consider this concept, this become E1, this become E2. Okay. So delta E is equal to E2 minus E1. Substitute the values. Okay. So we have minus 13.6, right? We have Z square upon N2 square minus plus 13.6 Z square upon N1 square. So delta E is equal to 13.6 Z square into bracket 1 upon N1 square minus 1 upon N2 square. Now this way we can calculate energy required for the excitation of electron. Okay. Now this relation plays a very important role, because if we continue this relation, we will further get one new formula called the Ritz equation, including the Rydberg's constant. So that also we have to discuss, because that is a basis for the hydrogen spectrum. And what will be the involvement and how the excitation of electron is taking place, that also we have to understand. So that we'll see in the next session. Thank you.